Alrighty, in this video we're going through the solutions for the vectors practice test. So with this test you should have the test itself, the formula sheet which is provided with the test, as long as your own A4 single-sided handwritten cheat sheet, and a calculator and stationery and everything. So let's make a start. We've got this one and we want to find v plus w both geometrically and also by drawing, geometrically and also by doing it algebraically. So let's draw in v and w. So v goes 2 across and 1 up. So that would be v there. And then w will go 2 across and 4 down. So that vector there is w. And then if I want to draw in a different color, maybe v plus w could be this vector across here. There it is. So it looks like from this diagram, v plus w, it looks to go across by 4 and down by 3. So 4 minus 3 visually. So that's the graphical method. And then if you want the algebraic, v plus w, that's going to equal, well, it's going to be 2 plus 2 on the top and 1 plus minus 4 on the bottom. And that's just adding up the components bit by bit. So what we end up getting is 4 with minus 3. At any rate, these do match, which is good news. All right, next thing we're going to do is find 2v, take a half w. So that's going to be essentially v will go up like that. There's one v, and then here's another v. And then take a half of w. So w would normally go across 2 and down 4, so it's going to go left 1 and up 2. So that's sort of pointing in the other direction, and it's half as long. All right, so that vector, what we would get, it'll look something like this from base to the tip. It looks to go across 3 and up 4. So visually, 2v take a half w equals, it appears to be 3, 4. Let's check that graphically. So 2v take a half w is going to be 2 lots of 2, 1. Take a half of 2 minus 4, which is going to be 4, 2, take away, or maybe I'll add it in as a plus, half of 2 is 1, so that's minus 1, and then half of 4 is 2, because 2 negatives make a positive there, which appears to be 3 and 4, which is exactly what we wanted, which is really good news. So yeah, that's good. All right, are v and w perpendicular? So the way you check if two vectors are perpendicular is you do the dot product, and then you check that that's equal to 0. So that's a formula that you get on your formula sheet here, perpendicular vectors. Two vectors are perpendicular if and only if their dot product is 0. Or in other words, v is perpendicular w if and only if v dot w equals 0. Okay, so let's work out v dot w. So that's going to be 2, 1, dotted with 2 and minus 4. Which is 2 times 2 plus 1 times minus 4, which actually is equal to 0. Therefore, v and w are perpendicular. As v dot w equals 0. That's all you need to say there. Find a vector which is parallel to v and twice the length of v. So that would be, well, if v is 2, 1, then what I can do is I can actually look at essentially the vector is just 2 times v. So that's 4, 2. I also think that technically, or minus 2v would also be correct, but I'm expecting not many people would have written that as an answer, even though both of these are technically correct. So if you want, you can actually work out the links. That one has a root of 2 squared plus 1 squared, which is root 5. And this one has root of 4 squared plus 2 squared, which is root 20, which is root of 4 times 5, which is root 4 times root 5, which is 2 times root 5. So yep, this actually works. But you don't need to actually check. As long as you've doubled v, that will double the length. You're allowed to assume that. So what I've written here is actually all you need to write. All right. V equals 5, 6, we'll find mod v. So mod v is going to be square root of 5 squared plus 6 squared, which becomes square root of 25 plus 36. 50, so that's square root of 61, I believe. Find a vector which points in the same direction of v, but has a length of 10 units. So the first thing we're going to find is the unit vector v hat, and I believe we have a formula for this. Somewhere, unit vector, yeah, 1 over mod v times v is how we find that unit vector. So this is going to be 1 over root 61 times by 5, 6. Or in other words, that becomes 5 over root 61, 6 over root 61. Now that vector has a length of 1, and it's pointing in the same direction as v. So therefore, the vector is 10 lots of v hat equals 10 lots of 5 over root 61 and 6 over root 61. Which if we want to step that out, that becomes 50 over root 61 and 60 over root 61. Cool, so there we go. What you can actually do is you can work out the length on your calculator. So if you want to get really fancy, you can go square root of the first bit squared, so 50 over root 61 squared plus, and then you can go 60 over root 61 squared. And then hopefully we get 10, which we do, so that's good news. All right, the vector 6k is perpendicular to v. We want to find the value of k. So if we know it's w is perpendicular to v, therefore w dot v should equal 0. Therefore 0 is going to equal whatever w dot v is. So v is, well, 6 with k is w. We're going to dot that with 5, 6. So 0 should be 30, take 6k, something like that. So the 30 comes from the 6 times 5 and then the 6k. But I think that should actually be a plus there because everything's positive for us. So therefore 6k equals minus 30. Therefore k equals minus 30 over 6. Therefore k equals minus 5, something like that. All right, good. So next step we want to do, we want to do question 3. So consider these 2 points. We want to find the vector AB. This vector is going to be, well, how do I get from 2 up to 10? I go up by 8. And how do I get from 5 down to minus 1? I go down by 6. The other way you can get this 8, for example, is you can do the second bit, so 10, take away 2, and that will give you the 8 there. If you prefer to think of it like that, it's up to you. Okay, consider the point C. It divides the ratio 1 to 2. Now we want to find the coordinates of that, should actually say C there. So, all right, so that's what we're going to do. So we're going to go A to B. Well, essentially, if I look at AC as a vector, that's going to look like, well, it's going to be a third of AB. Because if I think about A and I think about B, and I think about this point C, which divides it in the ratio of 1 to 2, C is like a third of the way through that. So that's going to be 8 over 3 and minus 6 over 3. And then what we can actually do is we can work out OC as a vector. That's like going from O to A and then from A to C. So that's like going 2, 5 plus 8 thirds minus 6 thirds, which I think gives you, well, 2 plus 8 thirds. So that's going to be 4.66 essentially. And then this 5 take away 2 gives you 3. So that should actually work. And then that is OC. Therefore, C has coordinates 4.66 and 3, if you like that. So that sort of should hopefully check out, because 2 and then 4.66. Yeah, it seems like it works. So that's good news for us. All right. Let V equal that and W equal that. We want to calculate V dot W. So that's what we're going to do. That's going to be 5 times 3 plus minus 1 times 2. So that's 15 take 2, which is 13. Calculate the angle between the vectors V and W. So we're going to use this formula here. Cos of theta equals V dot W over mod V mod W. and that's the formula for calculating the angle. So cos of theta equals 13 is v dot w over v is square root of, now 5 squared and 1 squared, so that's 25 and 1, so that's root 26 is mod v, and w is going to be 3 squared and 2 squared, so that's 9 and 4, which gives you root 13, something like that. And then theta is going to be inverse cos of that number, 13 over root 26, root 13, which should probably give you something. All right, so first things first, you want to make sure you're in degrees on your calculator. They're in a very similar menu on a Casio and a Texas. So on a Texas there, I hit mode, but on a Casio, I think I hit something like setup. Just verify that. So yeah, on this version, it's just going to be shift setup. Well, I think you need it already be in like the normal calculator mode, shift setup, and then the angle there for us, in this case, would be in degrees if we're on a Casio. But whatever way you do it, make sure you're in degrees, not radians. And then we're going to go inverse cos of 13 over, so we get root 26 times root 13. And that should give us 45, which is really cool. 45. So that's really good. So one thing that I'd encourage you to do when you get this is maybe draw yourself a picture of V and W. So V points out at 5 and down 1. So we're going to maybe draw V in like that. And there it is. And then W points 3 across and 2 up. So there's W. And I've actually drawn that to scale. Now, what I want you to do is sort of do a sanity check. Does that angle look like 45 degrees? It looks like it kind of does to me. It's about half of 90 degrees. So that's really good news, and we know we're sort of on the right track with that. Now this formula that I use, I think that is on your formula sheet as well. It's this one right here with the cos of theta. Next formula we need is for a projection vector. So we're going to pull that formula off the formula sheet. It's a dot b over mod b squared times b. So v dot w over mod w squared times w essentially will be what vector I'm looking for. Just underline everything. And that's formula for a projection vector. So v dot w we already discussed was 13 over mod w squared. Well, if mod w is 13, then, well, that's going to be root 13 squared. It's going to be a pretty boring projection vector, actually, not going to lie. But that's just a coincidence, really. Times 3, 2. So that becomes 13 over 13 times 3, 2. So our projection vector is actually just 3, 2 again. Pretty weird, but it is how it is. So that's our projection vector there. All right. So that should work out pretty okay. We'll just make sure we got the formula right. Yes, we do. So that's good. Okay, the next one we want to do is find the length. So there's a couple ways you could do this. We already do have the length of W, which was root 13. So if you want, that could just be your answer. But instead what we can do is we can use this formula for the length. It's mod A dot B over mod B. So that's going to be mod of 13 over root of 13, if you want, which is just 13 over root 13. Then you can times the top and the bottom by root 13. What you're going to get is 13, lots of root 13 over root 13 times root 13. There's a lot of 13s, but essentially that bottom just becomes 13 as well. They cancel off and all you're left with is root 13. So at any rate, you'll get root 13 as your answer. All right, next one we're going to do, we've got this question here. And what we're essentially trying to do in this question is to prove that this here is a right angle. And essentially that would be a right angle too. So that's the goal. Okay, so make sure you don't miss this mark here, really important. So let OA equal A and OB equal B. You're going to mark these vectors on the diagram. So there it is as A and B. That's one mark right there. Find A to B in terms of A and B only. So if I want to get from A to B, what I would need to do really is I'd need to go up through O and down to B, and I take that path. So what it ends up being is AB equals minus A plus B. There we go. And then we find OM in terms of A and B only. So if I want to get from O to M, this is a bit trickier. I'm going to need to go through vectors that I know. So I do know how to get to A, and then I could try to get from A to M, which is a bit tricky. But since we know that M is the midpoint there, this becomes OA plus just half of AB, something like that. Then what we're going to do is, we'll just put in what these vectors are. So OA is, we'll actually chuck arrows on here as well. There's arrows going down and down. OA is A plus a half of minus A plus B, just like that, which is A take a half A plus a half B, which gives us half A plus half B. Cool. All right. So hence show that AB.OM equals 0 and explain why this proves that our angle that we want actually equals 90 degrees. So yeah, pretty much what we're going to do is we're going to dot these two products together. So AB dotted with OM, that equals, well, AB is minus A plus B, and OM is going to be a half A plus a half B. So we're actually going to FOIL this out. We'll see what we get. So when we FOIL this out, we're going to get a half with A dotted with A. So that's going to be minus because we got a minus, and we're going to get a half, and we're going to get A dotted with A. And then next bit we're going to get is minus A with a half B. So minus a half A dot B. Now I'm just going to write that in alphabetical order to make sure we're consistent. This bit here, we're going to get plus a half of A dot B. And then this last bit, when we FOIL it out, we're going to get B and a half B. So that's a half B dot B. Now you're going to be really tempted to write that as half B squared, but please don't, because when you're working with dot products, there's no such thing as like squaring a vector. All right. So what we're going to do next is the middle two terms will actually cancel out because they're both basically the same. Just one's a minus and one's a plus. So what I'm left with is minus a half of A dot A plus a half of B dot B. Now we're going to use that formula that they've suggested we use. So when you dot a vector with itself, it's the length squared. So that's minus a half the length A squared plus a half the length B squared. And then, well, what we actually notice here is that A and B have the same length because we got an isosceles triangle. So this actually equals 0 because mod A equals mod B because OAB is isosceles, or like because OAB is isosceles. And we already said in the question that OA and OB have the same length, so it's important we use that. So pretty much if you think about A and B having the same length, then when I do this essentially is like minus a half of that length plus a half of that length squared. If A and B have the exact same length, then those two will just cancel out to give us 0. And explain why this proves. This proves it because AB is perpendicular to OM if and only if AB dot OM equals 0. Something like that. Okay, good. All right, next thing we're going to do for this proof is sort of just finish it off. So we actually use that formula that V dot V equals mod V squared, but I don't think we've ever actually proved it. So to make this complete, we're going to pretty much just prove that formula. So easiest way to do it is you just say something like let V equal x dot y. That's what you start with. Let V equal x and y, just like that. Then V dot V is going to be, well, it's x times x plus y times y, which is x squared plus y squared, something like that. But then mod of V squared, well, if we work out mod of V, that's root of x squared plus y squared, and then we're going to square the whole thing. So the square root and squared cancel, you're just left with x squared plus y squared, which these match, which is good. Therefore, V dot V equals mod V squared for any vector V. So we sort of completed that proof there now that we've also proved that formula that we used in it. Okay, last one we're doing here is the plane trying to fly from A to B, but the wind is blowing right at 50 k's an hour. So essentially what we do is if the plane tries to fly directly, what will its actual speed be? So it's going to be trying to fly forward at 300 kilometers per hour, and it's going to be blown right at 50 kilometers per hour. So its actual speed will be that length there. So speed equals the Pythagoras thing, so 300 squared plus 50 squared. It's like that. And we'll work out what that is. So hopefully it'll be a bit more than 300, because the wind's sort of making the speed go up in this case. So we can get 304.138. It's like that. Okay, so that's the actual speed. The plane wants to fly from A to B, so it'll have to fly slightly forward and also left to compensate for the wind. Calculate the angle the plane should fly at so that the wind corrects its position. So we're going to actually try and fly sort of up left here. So if we fly up left, then what we're going to get is we're going to get this vector here, up left. Now this is going to be at 300 kilometers per hour because that's what the plane's actually flying. And then we're going to be blown to the right at 50 kilometers per hour. And then basically what we want to find is this angle in here. So theta equals inverse tan of 50 over 300. Okay, so the reason for that is because we've got opposite. Sorry, I lied. It's not inverse tan, it's inverse sine, isn't it? Inverse sine of 50 over 300. Because we've got opposite over here, and then we've got a hypotenuse. Opposite and a hypotenuse is sine, so we're going to get inverse sine of that. Let's see what we get. Just again, make sure you're actually in degrees and not radians. That's really important. So inverse sine of 50 over 300 gives us about 9.594 degrees. I'm just going to say anti-clockwise from north. So that's the angle we need to fly at. The plane's actual speed, so this is going to be 300, this is going to be 50, and then the actual speed will be this missing length here. So that's going to be speed equals square root of 300 squared, take 50 squared. Now we're expecting this to be a little bit less than 300, just because, well, if the plane's using some of its speed to fight against the wind, it's not going to be going at that full 300 forward. So we'll just see what we get here. The actual speed ends up being 295.804. That equals 295.804 kilometers per hour.